Hello students, today we're going to learn section 6.3, Parametric Equations and Motions. When a third variable or component affects the equations, that's what a parametric equation is. The parametric variable is usually t, and it's time that usually represents a third variable. So you'll see x, y, and now t in 2-hour problems with section 6.3. So here's an example of a parametric situation. A rock is dropped from a 420-foot tower on the vertical line at x equals 2.5 with the equation y equals negative 16t squared plus 420. So now you could see three variables, three components, x, y, and t. So here is the description of this word problem. Let's say this is the tower. So here is the tower, and here's the vertical line, x equals 2.5. That's the red broken line. That's x equals 2.5. So a person is standing on the tower, 420 feet up, and they're going to drop the rock. So at t equals 0 seconds, you're now at 420 feet because that's where we're starting. So again, at 0 seconds, the rock is still at 420 feet. After 1 second went by, again, due to gravity, it's going downward. After 1 second, the rock is now at about 404 feet. After 2 seconds, the rock is at 356 feet. After 3 seconds, the rock is at 164 feet. And after 4 seconds, it's at 20 feet. So that's what we're talking about when we're discussing parametric equations. It's when a third component affects or relates to the equation. Okay. So in example 1, we're going to discuss how to graph parametric equations on your graphing calculator. Please make sure that your graphing calculator is in parametric mode. So go to mode, and then click on here function. It's usually in function, right? So you'll see this, but you don't want that. You want this. So go to mode, go to parametric, hit enter, and hit Y. So now I'll type in this equation. Automatically when you hit this button, it's t squared minus 2, and that is, the y is 3t. The window for part A, they want you to make the t minimum -3, there's -3, all the way to 1. So the maximum t value is 1. Just make sure you have your standard x minimum -10, x max 10, y min -10, y max 10. Okay? So when you graph it, that's the description of this parametric equation from the interval -3 to 1. Okay? To do part B, we're still using the same parametric equation, but you just got to change the window. So the window is now -2, minimum, maximum is 3, and we're going to graph, and that's your parametric equation for part B. That's the graph. And part C, again, you're changing the window. So now you're going to go from -3, 3 is already on the computer, on the calculator. So that is your parametric equation from -3 to 3. So again, parametric equations on the calculator to graph. Please make sure you put it in parametric mode. So go to mode, and then scroll down to parametric, hit enter, and now you're set to log in the two equations. Now, when you want to go back to graphing x, y, or y equals a line or a curve or a parabola, just go to mode and go back to function, hit enter, and then you're set. Okay, so that's how to graph parametric equations with certain windows. Next, we're going to go over, we want to eliminate the parameter and identify the parametric curve. So when they say eliminate the parameter, remember, we're eliminating that t value. Okay, so when we eliminate, select an equation where it's easiest to isolate t. Here we have a -2 in front of t. Here we have a -1 in front of t. Now, it doesn't matter which one you choose to go first. It'll just save you time if you analyze it first and choose the easier one. So for me, the easier one is to isolate t here. So I'm going to first work with the y equation. So get t by itself. Here's the work. I'm going to add t and subtract y on both sides. So now I have t equals 2 minus y, right? Because this and this equals 0, this and this equals 0. Next, you're going to take this t value and substitute it into your other equation you didn't use. So I'm going to substitute 2 minus y wherever I see a t in this equation with x. So there's the substitution. I simplified. So now we combine like terms. 1 minus 4 is -3. Add 3 to both sides. Divide by 2. So we have y equal, or x over 2 plus 3 over 2 equals y. But what we're used to doing is we're used to seeing it y on the left. So I just switch sides. Y equals 1/2 x plus 1.5. This is a linear equation with slope 1/2 and y-intercept 1.5. And those topics are from Algebra 1. Okay, so again, the first thing you're going to do is choose which equation is the easiest to isolate t. Example 3. We're going to do the same thing. So it's easiest to isolate t using the y equation because all we have to do is divide by 3. Here, if you start working with it, you have to add 2 and then take the square root. So always choose the easier equation. So we chose the y equation. So now t is equal to y over 3. Substitute this back into the x equation that you didn't use. So y over 3 squared minus 2. T is equal to y squared over 9 minus 2. If you multiply everything by 9 here, the 9's reduce and you have this equation here. Now to get y by itself, add 18 to both sides. I switch sides again. So y squared is equal to 9x plus 18. Again, going back to your previous math class, whenever the y is squared, it's what you call a sideways parabola. When we isolate y, y is equal to plus or minus the square root of 9x plus 18. If you put this in the calculator, you'll get your sideways parabola. Okay, so just to show you the sideways parabola, put square root 9x plus 18 okay, let's do it again. 9x plus 18, and this is going to be, you got to put a negative. So negative, and then do, again, the square root of 9x plus 18. Okay? And now we are going to graph, and there is your sideways parabola. Okay? All right. So next topic. Here we're going to do the same thing. We're going to eliminate the parameter, meaning the t. So in this case, it's going to be difficult for both. But what we're going to do with trig functions is if we can square it, even better. So I'm just going to take x squared plus y squared. Because when I substitute 2 cosine t in for x and 2 sine t in for y, we're going to get 4 cosine squared t plus 4 sine squared t. Factor out 4, which is our GCF. We have cosine squared t plus sine squared t. Well, isn't this 1 from our Pythagorean identities? So it's 4. So our equation is now x squared plus y squared equals 4. And if you notice, the t's are eliminated already. So we removed the parameter. We eliminated the parameter. The parameter, again, is your t value. So we have x squared plus y squared equals 4. That's a circle, again, in your basic graphs with radius 2. So we're done with example 4. In example 5, now they want us to do the reverse of what we did in examples 2, 3, and 4. Now they want us to find the parameterization for the curve. So this time, we're going to start off with points negative 2, 3, and coordinate 3, 6. So this is a line that has points A and B. This is just a general rule. Vector OP is equal to vector OA plus vector OP. So this right here is going to equal, OP is equal to vector OA plus T times vector AB. And here's the setup. X component XY is equal to, here is A plus T of AB. So remember, vector AB, it's head minus tail from the last lesson. So 3 minus a negative 2, comma 6 minus 3. So again, this AB, to get this value, remember, it's head minus tail. So 3 minus a negative 2, 6 minus 3. Again, we did this AB in the last lesson. So after we simplify it, AB is 5, 3. There's a t in front. So now to find the component vector xy, this is negative 2 plus 5t. Negative 2 plus 5t. This is going to be 3 plus 3t. 3 plus 3t. Well, to find the parameterization for the curve, you just use corresponding parts. Corresponding means same position. So x is first position. This negative 2 plus 5t is first position. Well, there is one equation. X equals negative 2 plus 5t because it's in the same position. First position, first position. Second position, second position. The other equation is y equals 3t. Y equals 3 plus 3t. So now you found the parameterization of the curve. Okay, so that's it. So example 5 is just the reverse process of examples 2, 3, and 4. Have a good day.